A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Alright, so the AI stack is getting fragmented. It's like we've got all these brilliant individual components. The models, the MCP servers, the observability dashboards, the routing logic, and they're all just sitting there, not talking to each other. It's a mess waiting for someone to glue it all together.
That's the core of Daniel's prompt today. He's asking about the emerging category of AI gateways as full-fledged middleware. The idea being, what if one layer could actually do that? What if you had a unified control plane that handles routing your requests to the right model, aggregates all your MCP tools, gives you observability and logging all in one go?
It sounds like the Nginx of the AI world, or maybe the Kubernetes ingress controller for agents, but less painful to configure.
Right. And that's exactly where the market is heading. For context, by the way, today's script is being generated by DeepSeek v22. But back to the topic. We've talked about pieces of this puzzle before. MCP aggregators, routing layers like LiteLLM, but Daniel's asking about the convergence, a single middleware solution that brings it all together. That's what's becoming critical as agentic AI moves from prototypes to actual production systems.
So let's define our terms. An AI gateway, in this new sense, is middleware that sits between your application or your agent and everything it needs to talk to. Models, tools, databases. It provides routing, aggregation, security, governance, and observability.
That's correct. The key shift is from these being separate, bolt-on tools to being a cohesive platform. Think about the progression. First, you had simple proxies to route API calls to different model providers. Then you had MCP servers popping up for every tool under the sun. Then you needed something to manage all those MCP connections. The gateway is the logical evolution, the single pane of glass, and the single control point for your entire AI infrastructure.
And the value proposition is pretty clear. Reduction in integration complexity, centralized security, cost management, and actually being able to see what your agents are doing. But I'm curious about the mechanics. How does this actually work in practice? It can't just be a fancy proxy.
It's not. Let's break it down into the components Daniel mentioned. First, model routing. This isn't just load balancing. A sophisticated gateway can dynamically select a model based on the task. Is it a simple classification? Route it to a cheaper, faster model like Claude Haiku. Is it a complex reasoning task requiring 100,000 tokens of context? That goes to GPT-4o or Claude 3.7 Sonnet. The gateway uses rules you define, cost, latency, capability, to make these decisions in real time.
So it's an intelligent router. It knows not to use a sledgehammer to crack a nut, financially speaking.
Precisely. That's a good way to put it, and this is where you see immediate ROI. Companies like Stripe have reported slashing their inference costs by 30, sometimes 40% just by implementing smart routing. They're not sacrificing performance, they're just not overpaying for every single request.
Okay, component 2, MCP aggregation. This is the part that feels most nascent to me. You've got your MCP server for your calendar, your MCP server for your database, one for your email, one for your internal wiki. An agent needs to potentially talk to all of them. Does the gateway just become a central MCP client that knows about all the servers?
More or less. It acts as a unified interface. Instead of your agent having to manage connections to a dozen different MCP servers, each with its own authentication and schema, it talks to the gateway. The gateway handles all those upstream connections, normalizes the tool definitions, and presents a single, coherent tool set to the agent. It massively reduces the integration complexity on the agent side.
And I suppose it also becomes the enforcement point. You can set policies at the gateway level. Agents can read from the Wiki MCP server, but they cannot write to it. Or, this particular agent can only use the email tool 5 times per hour.
That's the security and governance piece. It's a single choke point. You can audit all tool usage, enforce rate limits, require human approval for certain actions, all at the gateway layer. This is non-negotiable for enterprise adoption. You can't have autonomous agents running around making unbounded API calls with no oversight.
Which leads us to observability and logging. If everything flows through the gateway, it becomes the perfect place to collect metrics. What prompts are being sent? What tools are being called? How long do model calls take? What's the error rate? You get a unified audit trail.
And not just for debugging, for compliance, for cost attribution, for understanding agent behavior. This is the data you need to tune your systems. You might discover that 80% of your agent's time is spent on one particular tool that's running slowly, and that becomes your optimization target. Without the gateway, that data is siloed across a dozen different systems.
So the theory is solid. What does the landscape look like? Who's building these things?
We're seeing it split into two main camps, SaaS offerings and open source frameworks. On the SaaS side, a standout is Portkey AI. They launched their gateway platform in late 2024 and raised a $3 million seed round in 2025. They're positioning themselves as a full stack control plane model routing with fallback strategies, prompt management with versioning, observability dashboards, and they've been adding MCP aggregation capabilities.
And the open source side?
LiteLLM is the big one. It started as a simple Python library to standardize calls across different model providers, but it's evolved into a full proxy server you can self-host. It does the model routing, it has basic logging, and the community has been building plugins for it, including MCP integration. It's what a lot of tech-forward enterprises are using for their in-house solutions.
I've also seen Bifrost mentioned.
Bifrost is interesting. It's an open source AI gateway written in Go, so it's built for high performance. Its explicit goal is to unify LLM routing and MCP tool access through a single infrastructure layer. It's newer, but it's gaining traction with engineering teams that want something lean and fast and are willing to build on top of it.
And then there are tools like Helicon, which started more focused on observability and are expanding into the gateway space.
Right, the lines are blurring. Everyone who started in one piece of the puzzle, observability, routing, cost management, is expanding to become a full gateway. Because that's what the market needs, a single vendor, a single platform to manage.
Let's talk about the trade-offs. Building this in-house versus buying a SaaS solution. If you're a startup with 2 engineers, you're not going to build your own gateway from scratch.
No, you'd be insane to. For a small team, a SaaS solution like Portkey is a no-brainer. You get a sophisticated control plane from day one without the operational overhead. The value is immediate. The trade-off is, of course, vendor lock-in and ongoing subscription costs.
And for a large enterprise with strict security requirements and a team of platform engineers,
Then self-hosting an open-source solution like LiteLLM or building on Bifrost starts to make a lot of sense. You own the data, you can customize it to your heart's content, integrate it with your internal auth systems, your existing monitoring stack. But you're taking on the development and maintenance burden. It's the classic build versus buy calculation, but applied to this new critical layer of infrastructure.
so where does this leave the casual consumer? Daniel's prompt asks if these gateways have a role in more casual consumer AI use. I use a personal AI assistant. Do I need a gateway?
That's the million-dollar question. Right now, these tools are overwhelmingly enterprise-focused. They're about cost control, compliance, scaling to thousands of agents. The average person running a desktop AI assistant isn't thinking about multi-model routing or audit logs.
But maybe they should be. In a simpler form. Think about it. A casual user might still want to use multiple models. Maybe GPT-4 for creative work, Claude for analysis, a local model for privacy-sensitive tasks. Manually switching between them is a pain. A lightweight local gateway could handle that routing transparently.
And on the MCP side, a consumer might have a bunch of personal tool servers. One for their personal calendar, one for their note-taking app, one to control their smart lights. Having a personal gateway that aggregates those and manages access for their assistant, that's a compelling idea. It turns your AI assistant from a single model chatbot into a truly integrated, multi-tool personal agent.
The security argument gets personal too. I might not want my AI assistant to have unfettered access to my bank MCP server. A personal gateway could act as a guardrail. You can check my account balance, but you cannot initiate a transfer without a manual approval step I set here.
That's a great point. The governance isn't just for corporations. Individuals have privacy and security needs too. The challenge is the complexity. The current gateway solutions are built for developers. The UI is a YAML file or a Terraform module. For this to hit consumer use, we'd need a radically simplified, probably GUI-driven version, something you install like a password manager, point it at your tools, and set rules with a simple toggle interface.
So the technology is there, but the product market fit for consumers isn't quite baked yet. It's an enterprise tool looking for a consumer analog. I could see a company like Reclaim.ai, or even a new startup building a personal AI gateway as a desktop app. Man, that's a good startup idea. You're welcome, listeners.
I'll take 10%. But to your point, yes, the architectural pattern is universally useful. Centralized control, aggregation, security. It's just that the implementation and priorities are different at scale versus in your home office.
Let's dig into a specific case study. You mentioned cost savings. How does that actually play out with a tool like Portkey?
There was a mid-sized SaaS company, about 150 employees, that deployed Portkey. They had a customer support agent that analyzed tickets and suggested replies. Initially, it was just hard-coded to use GPT-4 Turbo for everything. Their monthly OpenAI bill was significant.
Let me guess. They were using a $1,000 model to say, "Have you tried turning it off and on again?"
Basically, they implemented Portkey with a simple routing rule. If the ticket classification model, which was a tiny cheap call, detected the query as simple or routing, it would send the actual response generation to GPT 3.5 Turbo. Only complex, nuanced tickets went to GPT-4. They also set up fallbacks. If OpenAI was having an outage, it would fail over to Claude instantly. The result was a 35% reduction in their monthly inference costs, with no measurable drop in support quality. The gateway paid for itself in about 6 weeks.
That's the kind of concrete ROI that gets CFOs to sign off. It's not just cool tech. It's a cost center that suddenly becomes a lot more efficient.
And that's just cost. The observability piece let them see that their agent was making redundant calls. It was calling the search tool, then calling it again 2 seconds later with nearly identical parameters because of a logic bug. They fixed that and reduced overall tool usage by 20%. The gateway became their source of truth for understanding and optimizing the entire AI workflow.
It feels like we're describing the maturation of a technology stack. Early days, you're making direct API calls from your application code. It's messy, but it works. Then you add a library to abstract it. Then you realize you need a proxy to handle retries and load balancing. Then you need observability, so you bolt on logging. The gateway is the recognition that this is now a fundamental piece of infrastructure, worthy of a dedicated, integrated solution.
That's exactly it. We've seen this movie before with web applications. First, you write a server, then you need a reverse proxy, then you need a load balancer, then you need an API gateway, then you need a service mesh. Each layer emerges as the system scales and the needs become more complex. AI agent systems are hitting that same inflection point.
So what are the limitations? What can't a gateway do?
It can't magically make your agents smarter. It can't fix bad prompt engineering. It's infrastructure, not intelligence. Its job is to make the intelligent components you have work together reliably, securely, and cost-effectively. Also, it introduces a single point of failure. If your gateway goes down, your entire AI operation grinds to a halt. That's why high availability and redundancy are built-in concerns for these platforms.
And it adds latency. Every request now has to hop through the gateway. The trade-off is that the benefits routing, aggregation, security outweigh that millisecond penalty for most use cases. But for ultra-low latency applications, it might be a concern.
A valid concern, but a well-implemented gateway adds minimal overhead. We're talking single-digit milliseconds for the routing logic. The time saved by avoiding a model outage or by using a faster, cheaper model usually more than compensates for that.
Let's talk about the future. Where is this going? Daniel's prompt is about emerging tools, but what's the next evolution?
I see a few directions. First, deeper integration with the agent frameworks themselves. Right now, gateways are mostly separate services your agent calls. What if the gateway logic was embedded within the agent runtime? A tighter coupling could enable even more dynamic behavior.
Second, I'd say standardization. We have MCP as a standard for tools. We might see the emergence of a standard for gateway-to-agent communication, an open protocol that lets any agent work with any gateway. That would prevent vendor lock-in and let the best components win.
And third, intelligence. Right now, routing rules are mostly static. If condition X, use model Y. The next generation could use reinforcement learning to optimize routing in real time based on live performance and cost data. A self-optimizing gateway that learns the most efficient paths for your specific workload.
That starts to sound like an AI for your AI, which is beautifully meta.
It is, and it points to the ultimate role of this layer. As AI systems become more autonomous and complex, you need a control plane that's equally sophisticated. Not just a passive pipe, but an active, intelligent manager of your AI resources. That's the destination.
So, practical takeaways. For our listeners who are engineers or architects working with this stuff, what should they do?
First, if you're building anything beyond a prototype with AI agents, you need to be thinking about this gateway layer. It's not premature optimization anymore, it's technical debt waiting to happen. Start evaluating. Set up a proof of concept with LiteLLM. It's open source, you can run it locally, see what it gives you, get a feel for the observability, try out some routing rules.
Second, for teams that are scaling, look at the SaaS offerings, Portkey Helicon. Do a trial. Calculate what your current shadow infrastructure costs are. The developer time spent managing API keys, writing retry logic, building dashboards, and see if a managed platform saves you money and headaches.
And for the more casual users, the hobbyists, the early adopters running personal agents, keep an eye on this space. The concepts are powerful. While the current tools are overkill for you, the pattern will trickle down. Look for simplified, consumer-friendly versions of this idea. Or, if you're technically inclined, consider running a lightweight gateway like Bifrost on your home server. It could be the brain for your smart home AI.
The overarching takeaway is that the era of duct-taped AI scripts is ending. We're moving into the era of AI infrastructure, and the gateway is the keystone of that infrastructure. It's what turns a collection of clever but fragile scripts into a reliable, observable, governable system.
Which is exactly what needs to happen for this technology to deliver on its promises in the real world. You can't have mission-critical business processes depending on a Python script that breaks if an API changes. You need a platform. And that's what's emerging.
It's a sign of a maturing ecosystem. The Wild West is giving way to, I don't know, settled towns with proper sheriffs and paved roads. The gateway is the sheriff.
And the paved road. And the town hall. I think your metaphor is breaking down.
It's been a long episode. Alright, to wrap up. The open question is, how ubiquitous will this layer become? Will every AI application, big or small, eventually sit behind a gateway? Or will it remain primarily an enterprise concern?
My bet is on ubiquity. As the tools get simpler and the benefits become clearer, it'll become a standard part of the stack. Just like you wouldn't build a web app without a reverse proxy today, in a few years you might not build an AI agent without a gateway.
A future where our AIs are better managed than our cloud bills. We can only hope. Thanks as always to our producer, Hilbert Flumingtop. And big thanks to Modal for providing the GPU credits that power this show.
If you're enjoying the show, a quick review on your podcast app helps us reach new listeners.
This has been My Weird Prompts. We'll catch you next time.
See you then.
This episode was produced using DeepSeek v3.2. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts, that's the close from slow